So we're talking about cylinders and cones, and a cylinder is a solid consisting of two parallel congruent discs and all the points in between them. And another word for disc is circle. So it's saying we have two circles, two discs that are parallel, and all the points that are in between them are going to make up the cylinder. So is it true or false that a cylinder is a polyhedron with circular bases? That is false. And the reason is because a polyhedron must have sides that are made up of polygons. Well, circles are not polygons because circles are not straight. They are rounded. And that automatically takes them out of the polygon running. And so that means they're also not polyhedrons. It asks you for two ways to construct a cylinder. Well, the easiest way to construct one is to draw two circles. Draw two parallel circles. And specify that. And connect them. And that, just like I did in the one, the pink one up here. That's how the easiest way to actually construct a cylinder. So the difference between a prism and a cylinder is that in a cylinder, the bases are circles. Otherwise, they're exactly the same. So even the side is actually a rectangle, just like in a prism, all the sides are rectangles. So a cone is a solid made from a disc, a point, not in the same plane as the disc, and all the points in between. So what that means is it's a disc, a circle. A point that's not in the same plane means that it's going to be above it, and then all the points in between. So if you were to connect the lines, then you would get connect the point to the base, you would get the shape of the cone. So it says describe the difference between a pyramid and a cone. Well, the difference is that a cone has a circular base. When it asks you to describe two ways to construct a cone, well, the easiest way to construct a cone is to draw a circle, draw a point, and connect them. Okay, true or false? Aside from the vertex, the cross-sectional shapes parallel to the base of a cone are all similar. Well, what that's saying is if I took a cone like this, and I cut it here, and here, and here, and I looked at those shapes, well, it's always going to be circles, and they are going to be similar because the further up the pyramid I go, the smaller the circles are. So here the circle would be this size, and then it would be this size, and then it would be this size, and if I was down here, it would be even bigger. So that is true, that aside from the vertex, the cross-sectional shapes parallel to the base of a cone are all similar. So below it says label each solid along with its bases and vertices. So this first one here is a cylinder, and we would call this technically a right cylinder because it's completely straight up and down. This would be called an oblique cylinder because it's slanted. This is called a right cone. And this is called an oblique cone because it is slanted. So I'm going to color all the bases in blue. You may want to get a blue marker, or you can label these as your bases. It doesn't matter. And it asks you to label the vertices. Well, vertices, I'm going to label those in purple. So vertices are points. Well, cylinders do not have vertices. Only cones have vertices, and they only have one vertex, technically. So they gave us a few more shapes here. Well, this first one would be considered a right pyramid. This one would be considered an oblique pyramid because it's slanted. And the reason I knew it was a pyramid was because they had one base and they had a vertex. Here and here. Okay. And then this next shape would be a right prism, I'm sorry. And the last one would be an oblique prism.
It said error for lot 1. For lot 2 it said.
And the reason I knew these were prisms is because they had two bases. They both had two bases. And this time their sides it wasn't circular, and they did have a lot of vertices. So I'm going to label again all the vertices in purple. So each of them has 6 vertices. So the last thing is that blank and blank both have only one basis, and that is that pyramids and cones both only have one base.